Hi, I'm matttheewshotton from BBC R&D. I'm really excited today to be able to present the video context here at textAV. The video context is a media rendering engine for the browser. It lets you programmatically do anything you would traditionally do in a non-linear video editor, but it also goes one step further, allowing you to dynamically manipulate these compositions in real time. You can sequence new clips, tweak effects parameters, and a whole bunch more. The video context has two main functions. The first is sequencing and clipping of media. This allows you to create playback timelines that seamlessly combine multiple video, images, and canvases. The second is a graph-based media processing pipeline. This allows you to construct complex video processing chains that use WebGL to be fast and efficient. It allows the creation of effects and transitions such as chroma keying and crossfades. Let's dive straight into an example of how you might use it. Here's an HTML document that shows the video context being used. At the top, we're importing the video context script. Then we have a canvas, which we're going to use as our rendering output of the video context. Then we have the code for performing the composition. I'll focus on the code and we'll go through it step by step. First of all, we'll create a new instance of a video context class. To do this, we get a handle to the canvas on the page and we pass it into the video context constructor. Next, we create two image source nodes. We do this by passing in the URL of the image that we want the node to output. We then connect those nodes into the rendering graph. And in this instance, we'll be connecting them straight to the video context destination. The video context destination represents the canvas that things will be finally rendered to. Then we sequence the playback of the two image nodes. So the first image node, we're going to play from time 0 to time 4. The second image node will play from time 4 to time 8. Finally, we'll call play on the composition, and this will start the rendering. Here we can see a graphical representation of the processing graph we've just created in code. On the left-hand side are the two image nodes, and on the right-hand side is the destination they're connected to. And now we can see the rendered output, two pretty awesome space cats. I've also added some extra debug information on this page, such as the timeline beneath the rendered image showing when the images are playing, and a live visualization of the rendering graph on the right-hand side. Okay, we've created some images, now let's add in some video. So, we'll create a video node. This is done in a really similar fashion to an image node, and we'll pass in the URL to a video we want to play. Next, we'll connect that video into the processing graph in the same way we've connected the image nodes straight to the destination. And finally, we'll sequence the playback of that video from time 0 to time 8, so it'll overlap both of our images. Here's our new image rendering graph. As you can see, we've added a new video node on the left-hand side, which is also connected to the destination. And here's what it looks like now it's rendering. Unfortunately, the video has been overlaid on top of our two cat pictures. Fortunately, the video of Shia LaBeouf is backed by a green screen. Let's go around the loop one more time and try and fix this. The video context has a number of built-in effects. One of these is a color threshold effect that will let us turn that green color transparent. Let's add a color threshold effect into our composition. To create the effect node, we need to pass in an effect definition into the video context. An effect definition is a JSON object that contains vertex shader and fragment shader code, along with a few other useful bits and pieces. You don't need to know how to write shaders to use the video context, as it has a number built in, but it does provide quite a nice fun framework for playing around with them. The next step is to connect the video node to the color threshold node rather than connecting it to the destination. Then connect the color threshold node to the destination instead. This is what our new video processing graph looks like. As you'll note down the bottom, the video node is now connected to the effect node, which is then in turn connected to the destination. This means that any video played out of the video node will be run through the shader inside the effect node before it gets rendered to the destination. And this is what our rendered output now looks like. As we can see, Shia LaBeouf is now beautifully laid over the top of our space cats. Hopefully that gave you a good idea of how to get started programming with the video context. There's a bunch more features I haven't had time to cover, such as transitions, callback support, and clipping of video files. If you'd like to learn more about these features, please visit the GitHub repository, where there's documentation and a number of examples. And now I'd like to show a quick demo of an internal prototype we built using the video context that explores the future of broadcasting.
Forecaster from the BBC R&D Labs demonstrates how a new approach to delivering programmes would open the door to more personal, flexible experiences for our audiences. In this demonstrator, we transmit each of the media elements separately, and because of this, we have the ability to control each of these individual elements in isolation from one another. The timeline tracks you see at the bottom of the footage represent the timelines for each media object in the forecast. To illustrate this, you can see how the on-screen graphics can be toggled on or off, or the whole backdrop removed to reveal the raw green screen footage. By delivering content in this way, one of the biggest potentials lies in the enhancement of accessibility, replacing the standard presenter with a signer as a first-class presence in the video, for example, or rearranging the on-screen graphics when subtitle elements are present to avoid overlap. You could also change the background map to a higher contrast view to aid the visually impaired. If media were delivered in this way, we could also have the footage adapting to suit your screen size, rather than forcing a single aspect ratio or font size on all devices. Here, we can see how a mobile portrait view would look, with a larger font size and a rearranged view to include more of the map. In the future, we could also link content to your personal calendar or other third-party data services and feature relevant local information. As you can see, the ability to send media elements or objects separately rather than as a single video stream gives much greater flexibility for playback, allowing content to automatically adapt to the screen size and preferences of the viewer. The flexibility of an object-based approach won't just benefit audiences though. BBC R&D is also testing how it could make production more efficient, giving programme makers time to flex their creative muscles in new ways.
Hopefully this talk has given you an overview of some of the exciting possibilities enabled by the video context. I'm always really excited to see what people build, so do get in touch if you have a play with it. Or if you have any questions, comments or feedback, drop me a line via Twitter or email. Thank you very much for your time, and I hope you enjoyed the rest of the event.